So we're on to page 3. And number 13 has a negative exponent in it. So remember, a negative exponent means that we have to make that happy. We don't want it to be negative, and write it so that it's 1 over x to the positive first. So we have x minus 1 over x, and then divided by, and I'm going to write that other fraction in here. Why don't we factor that? It'll be x plus 1 times x plus 4. Because factors of 4 that add up to 5 are 1 and 4. And then the denominator, if you look at that, we have a GCF of x. So I'm going to factor out that GCF. And what do you notice? We can actually simplify this fraction before we even look to see what to do with the numerator. So I'm going to use a different color here. We have an x plus 4 in the numerator and the denominator, so I'm just going to cross those off. If we simplify early, it will make our life just a little bit easier later on. So we need to change this into a single fraction. So what do? I'm going to do x times x, so that's going to be x squared minus 1. And it's all over x. Well, x squared minus 1, hopefully you're saying, well, that's a difference of squares. So we can factor that x squared minus 1 to be x minus 1 times x plus 1. And we have division still, so we can change that to multiply, and we'll take the reciprocal, x over x plus 1. All right. So let's check, can we do any simplifying here? Well, we have an x in the denominator of the first fraction, an x in the numerator, so that becomes a 1. And then there's the x plus 1 as a factor, and x plus 1 here. That becomes a 1, and what's left? Just x minus 1. So 13 simplifies to x minus 1. All that simplifies just to a binomial. All right, I figured we'd do 16 together because that's a little bit more difficult when you look at it. So for 16, let's look at our problem here. We have u minus 5 over u plus 4, over u minus 4, plus u minus 4 over u. So we need a common denominator. So I'm just going to work on that part right here. So the common denominator for the numerator would be u minus 4 times u. And my u's and 4's look to be the same there, so let me just fix that. So u minus 4 times u. So now the numerator is going to be u minus 5. And what did we have to multiply into that denominator? U? I'm going to put that up front because it's easier to distribute. And the other numerator was u minus 4 to begin with. And we actually multiplied by u minus 4 here. So I need to multiply by another u minus 4 there. Even though we already have one binomial, we multiply the denominator by u minus 4, so we have to do that to the numerator as well. Let's distribute. So I get u squared minus 5u. And then here I get u squared minus 8u plus 16. Combine our like terms. Well, we get 2u squared minus 13u plus 16 all over u times u minus 4. All right? And this again is divided by. So now I'm going to do the same thing I did for the numerator, for the denominator. I'm going to do that over here. And I'm going to change the color. What would our common denominator be? Well, it'd be u times u minus 4. Now, what did I multiply this by? I multiplied it by u minus 4, so I have to multiply that u minus 5 by u minus 4. And I noticed some of you are putting parentheses around the original binomials. You want to make sure you do, otherwise technically it's not right because you would just be distributing that 5. So do put those parentheses there. For the second part, I just multiplied by u, so I'll multiply that numerator by u. All right, so I'm just going to work on the numerators down here. So when I have u minus 5 times u minus 4, I get u squared minus 9u plus 20. And then this will become plus u squared minus 5u. Okay, so let's combine our like terms. We get 2u squared minus 14u plus 20. And it's all over u times u minus 4. So I'm going to put these together. And when I do that, this is going to be my first fraction. Notice I have u times u minus 4 here. I'm going to change it from division to multiplication. And now this denominator will be here. Notice it's u times u minus 4. So what's nice about that? They are going to cancel out. So make sure I cross that u out as well. Now the numerator here was that 2u squared minus 13u plus 16. And this numerator now became the denominator because we changed it to multiplication. I can factor out a 2 here because that's my GCF. And now I'm going to look. Will this factor into anything that will cancel with that numerator here, that 2u squared minus 13u plus 16? And the answer is it will not, because the factors of 10 are 2 and 5. And although we do have a 2 and a 8, a 4 and a 4 here, nothing will actually factor. Now, if you were doing that on your own, you might spend a little bit more time doing that out just to prove it to yourself. But this is as good as it gets. Now, I have that GCF of 2 factored out, but you could have left it as 2u squared minus 14u plus 20. It's just easier to check if you can simplify by factoring out that GCF. So this is the answer to number 16. All right, so now we're going to switch gears. I'm going to show you again how to solve the equations, and you have to make sure you do check for your extraneous solutions. So the first thing I'm going to do is check, can I simplify any of the 3 fractions in my problem? The answer is no. So now I want to clear my fractions. I want to get rid of these. So I want to multiply each term in this equation by the least common multiple. So I notice this has a 4 in it, this has a 2, so I know I have to multiply by 4. And then we have a squared. So we're going to multiply by 4a squared. So each term, and I like writing it, even if I'm doing it on paper, in a different color, so that I can make sure that I am multiplying every single term by that 4a squared there. So when I multiply the first term, that 1 over a squared, by 4a squared, the a squares cancel out, and I just have 4 times 1, which is 4. Now I have a minus sign. When I multiply 1 over 2a by 4a squared, well, the 4 and the 2 divide to give me a 2, and then a squared and a leave me with an a, so I have minus 2a. And then the last term, 4a squared divided by 4a squared is actually 1. So I'm left with 1 here. Don't make it 0. We still have a 1. So we'll subtract 4 from both sides. I get negative 2a equals negative 3. And then I divide by that negative 2. And I get a equals positive 3 over 2. Now what I want to do, and I scribbled all over it, but if a is 3 over 2, would that make any of my denominators 0? No, it does not. So that's my solution, 3 over 2. I'm going to put it in set builder notation. All right, so you are going to try the other 3 on your own, but I just wanted give you a quick reminder for 8 before you try that. Remember, this 4 is like a 4 over 1. So you might want to write that in when you're doing those. So try those next 3 out. Check your answers. Email us if you're stuck or you have questions, and we'll do the last page of the review in video 4.